Previously on Virtual Math with Mr. Ferrara.
Previously on geometry, chords. Watch the video.
It's Virtual Math with Mr. Ferrara.
Oh hey, I didn't see you there. I was just about to get started with our geometry lesson, 10.5, secants and angle measurement. Print out the PowerPoint, work the problems with me. Let's get started.
Hey, what's up everybody? Today we're going to be doing section 10.5, secants and angle measurement. We're going to be breaking this section into two. Today we're only going to be talking about secants and angles that are created. First question is, what is a secant? A secant is a line that intersects the circle at exactly 2 points. In other words, it's a line that swipes through the circle, touching the circle at exactly 2 points, where it enters the circle and where it exits the circle. If you look at the picture at the left, line EF, or line AB, depending on how you want to name it, are the secants. AB is only a chord if you list it as a segment, like the last line in the slide. There are two possible situations when drawing secants into a circle. The first possibility is when those two secants meet inside the circle. When the two secants meet inside the circle, they form angles and intercepted arcs. The angle is 1/2 the two arcs added up. The two intercepted arcs added up, then divided by 2, equals the angle that created them.
Pause the video here, try the next two problems on your own, and let's compare answers. All right, the first two examples deal with secants that meet inside the circle. And when secants meet inside the circle, you add up the two arcs and then divide by 2. Take a look at the first example. We have arcs that are formed by secants that are meeting inside the circle. So I know that the two arcs that are inscribed are 202 plus 52. Cut those in half, that'll make my angle. 202 plus 52 is 254. Half of 254 is 127 degrees. So X is 127 degrees. If I wanted to go further, I could find this angle right here. These two are supplementary. So 180 minus 127 leaves us 53 degrees. This angle down here is also 53 degrees, and this angle is 127 degrees. So based off of two arcs, we can find all of the angles of those two secants. Problem number 2 is very similar. Angles formed inside the circle using the arcs. However, this time we're missing an arc, not the angle. Still going to use the same process. The angle equals 1/2 of the two arcs. Well, one of the arcs is X, the other arc is 112. The angle is 94 equals 1/2 X plus 112. In order to get rid of that 1/2, I'm going to multiply both sides by 2. Multiply this side by 2. 9 times 2 is 188 equals X plus 112. Subtract 112 from both sides. We get X to equal 76 degrees. So the arc is 76 degrees in that picture.
The second possibility is when the two secants meet outside the circle. The angle would be formed outside of the circle. In this case, instead of adding the two arcs together, you'll subtract the smaller arc from the larger arc. So the angle equals 1/2 x minus y, where x is the larger arc and y is the smaller arc. There are three possibilities of what this would look like. One of them is two secants, still x minus y divided by 2. The second possibility is when you have a tangent and a secant come together, again, 1/2 x minus y. And the third possibility is when we have two tangents, again, x minus y divided by 2.
Hopefully you did well on the last problems. Pause the video again, and let's try the next couple. All right, problems 3 through 6 deal with a mix of problems, most of them having the secants meet outside the circle. So in this first problem here, we have secants that are meeting outside at x. Whenever the angles meet outside, we subtract. So it's 1/2 bigger arc minus smaller arc. 1/2 big arc minus small arc. 240 minus 70 is 170, and half of 170 is 85 degrees. So this angle out here is 85 degrees. When the secants meet outside, subtract, then divide by 2. Problem 4, same type of setup, except we're missing the arc, not the angle. So, same idea as before, angle equals 1/2 big arc minus small arc. So the angle equals 1/2 268 minus x. I know the angle is 82, and that's 1/2 of 268 minus x. I'm going to get rid of that half by multiplying by 2. 164 equals 268 minus x. Subtract 268 to the other side. When I subtract 268 to the other side, I get negative 104 equals negative x. Divide both sides by negative 1. I get 104 for x. This arc is 104 degrees. If you want to check, 268 minus 104 divided by 2 does give me 82 degrees. Now, let's do a little bit more of an algebraic type of problem. The only thing they give me is 80 degrees for the angle, but I do notice that both of these are tangents, which means they touch the circle at exactly 1 point each. To make this easier, I'm going to assign this arc from here around to here x. If that part's x, the remainder of the circle is whatever 360 is minus that x. So this smaller section is 360 degrees for the whole circle minus this section of x. So x is the big arc. 360 minus x is the smaller arc. 1/2 big arc minus small arc equals the angle of 80 degrees. 1/2 big arc minus small arc equals 80. Get rid of this half by multiplying. X minus 360 minus x equals 160. I'm going to distribute this negative 1 to both terms. X minus 360 plus x equals 160. Combine my like terms, x and x gives me 2x minus 360 equals 160. Add 360 to the other side, I get 2x equals 520. And if 2x equals 520, divide both sides by 2, so x equals 260. So this arc, this large arc, is 260 degrees. And if this arc is 260, 360 minus 260 means this arc is 100. Here's how you can check. 260 minus 100 is 160. 160 divided by 2 is 80 degrees, which is what we had to start with. The last problem is a mixed review. It mixes up some inscribed angles with some of this secant stuff. So I see a 72 degrees right here. If that's an inscribed angle, inscribed angles are always half of the intercepted arc. So that means CA would be double 72 or 144. If this section's 144, from C to B to A is the rest of the circle. 360 minus 144 leaves us from here around this way That leaves us 216 degrees. Now the reason I did that is D, angle D on the outside of the circle, is made by this 216 degree arc and this 144 degree arc. When it meets on the outside, we subtract. 216 minus 144, all of that cut in half will equal angle D. 216 minus 144 is 72. So we're taking half of 72. So half of 72 is 36 degrees. So angle D is 36 degrees. If you have any questions on today's assignment, please feel free to Schoology message me, email me, call the Google helpline, or ask your questions during our next live conference. Till next time, bye.